Okay. Okay. This is a BD35F compressor by Seacop. The control module is a 101N0500, and there's also Danfoss there. Okay. The fridge itself came out of my boat. It's a few years old, and it is a NR. You can see that. It is a NR 751 BB model by Norcold. Anyways, trust me on that. So here's what it's doing. It's not getting cold, and what's happening is when the fridge is oh, first of all, let me just take you a bit of a tour here. Okay, this is the compressor in here, compressor motor in here with the inside the refrigerant. Okay, this is the fan. Underneath the fan is the evaporator, and behind here, of course, is the condenser coils. Control module. So this is both a 12 volt. This is a 12 volt input and 110 volt alternating current. So when I'm on the water and away from the shore, not plugged in, it runs off the boat battery. As soon as I plug into shore power and get 110 volts, here, the 110 volts comes into the control module. The control module senses it has 110 volts and switches from 12 volt input to 110 volt input. And yeah, I should also mention that there must be some kind of transformer in here to transform 110 volts down to 12 volts. So I think one of three things is happening. I should also mention that when the compressor turns on in my boat on battery, the lights dim. It's kind of weird. So I think the first thing that's happening, this is what's happening, is it only happens on when I'm plugged into the 12 volt power. It doesn't happen on 110 volt. The fridge works perfectly on 110 volt. What I think is happening is when the compressor turns on, there's a heavy initial draw of current, and that is dragging down the battery voltage, and the control module is shutting off the compressor to prevent the compressor from excessive current draw because of low voltage. And yes, low voltage on a motor causes the motor to turn slower, which causes an excessive current draw, which could damage the motor. It could burn it out. I won't explain why. You'll have to study your electric motor theory to figure that one out, but it's true. So I think one of three things is happening. Number one, either the compressor has developed a problem and there's an excessive current draw, which is causing the battery voltage to drop too low, which is causing the control module to shut off the compressor. Now also, I should mention the batteries in my boat are 7 or 8 years old, I think. Yeah, 7 or 8 years old. That's about the life of a battery. I can't really expect to get a lot more of it, even though I really can't fault it. I can't diagnose any kind of fault in the battery. The third thing that might be happening is because the boat is 20 years old, and then for each but you know, the battery and the fridge are pretty far apart, and by the time the battery voltage comes all the way to the fridge, every single connection in the battery is a small voltage drop, all those voltage drop adds up. The voltage drop is caused by maybe a little bit of corrosion, and that's causing the voltage to drop a little too low, and then the control module is shutting off the compressor again to protect it. So one, or a combination of those three things, is, I believe, what's going on here. Okay, so let me show you what's happening with this setup here, and how I plan to fix it. I personally think that replacing the boat batteries is going to fix it. I'm not sure. So first of all, I have an old car battery. It's pretty weak. And I have a 2 amp trickle charger, which is actually not enough to charge the battery while the compressor is running. Okay. This device here, I don't need my light anymore. Okay, this device here is a step-up transformer. I bought it from eBay for about $4. Okay, you just search for Arduino, Arduino, step-up transformer on eBay, and you'll find it. This is 120 watts. It'll step up a voltage to about, I believe, 0 to about 30 volts in the maximum. Okay, so here's how I have everything connected. The step-up transformer, these two are the input voltage for the step-up transformer. These two are the output voltage for the step-up transformer. So these two go to the battery. Okay, the battery voltage comes in here, it steps it up, and it outputs here. These two are connected to the fridge. This is an ammeter, okay, this is an ammeter that is measuring the current that's going to the fridge. This is the running current of the compressor. So the compressor right now is drawing 3.85 amps at 14.5 volts. And that's powering the compressor, the fan, and the light. Okay. This one here is measuring. This one here is measuring the, can you see it? This one here is measuring the open circuit voltage of the battery itself. Okay, so the battery charger is charging at 2 amps. The fridge is drawing almost 4 amps. So you can see that actually the battery charger is actually inadequate, but I kind of did that on purpose. Okay, so here's what I'm planning to do here. Is the input voltage going to the step-up transformer is only 11.6 volts. The step-up transformer is 120 watts, and it's stepping it up to 14.5 volts. Okay, the fridge is drawing 3.83 amps. So the fridge is drawing roughly 4 amps at 15 volts. 50, 30, 60. So roughly around 60 watts. Okay, so this is 120 watt. So it has a continuous draw about 3.8 amps. This is about 120 watt step-up transformer, and I have the door open right now, which is why the fridge is not cycling off. Okay, and that's what's happening now. So what I'm hoping to do with the step-up transformer is, if the battery voltage is a little too low, okay, for the control module to like, I guess you could say, what I'm hoping will happen is that the step-up transformer will prevent the step-up transformer will prevent the control module from shutting it off. And you can see that it is kind of working right now. And if this does work, what I might do is I might wire this thing to the back of the fridge and kind of keep it there. Alright, so what I want to show you here is that this is the current draw going to the step-up transformer. Any kind of step-up transformer or step-down transformer, there's going to be an efficiency loss. It's not going to be a perfect conversion when you jump a lower voltage to a higher voltage. You can see here that there's some heat dissipating, and it is actually getting a little bit warm. Okay, and that heat is lost efficiency. So this is drawing 4.5 amps. Okay, at 11 almost 12 volts. Okay, so that's what the step-up transformer is using. The fridge is using 3.8 amps at 14.5 volts. Okay. Now, what I'm going to do is I want you to watch this. What I'm going to do is I'm going to disconnect the fridge. I'm going to reconnect it. Okay, so I'm going to disconnect it, and then when I disconnect it, watch. When I disconnect it, you'll see that the amperage goes way down. Okay, because everything's going to shut off, obviously. Okay, so as expected, everything goes down. All right. Now, when I reconnect this thing with any electric motor, once you connect it for the first time, it's going to have a high initial draw. Okay, so this is going to jump up. This is going to jump up a little bit. So you can see the open circuit voltage of the battery, okay, is measuring 14.8 volts. Okay, now watch this. See if we get all that. I can't. Hang on a sec. See, put this over. It's taped down. Okay. All right. So watch this. I'm gonna connect these two back together. The fridge will turn on. Let's take a look at the initial draw of the fridge, and this is why my lights turning off, are flickering. My bulb, maybe because my battery's weak too. So let's turn this on and let's take a look. Okay, that didn't. Oh, there you go. Okay, so okay, so it has a high draw of roughly 4.5 amps. The step-up transformer is holding steady at 14.3 volts. Okay, and let's just let it run for a while. And as the motor, as the compressor runs, I'm going to guess that's going to come down to a more normal voltage of, or more normal amperage of under 3 amps. And you can see that it's already decreasing. So as it's running, as it's compressing the refrigerant, the draw gets lower. And you can see the open circuit voltage has dropped to 11.5 volts. Now keep in mind that this is a really old battery. That battery's got to be over 10 years, way over 10 years old. The battery charger is inadequate to keep it charged while the fridge is running, and that's why the battery is low. That's why the voltage is low. Okay, and you can see here with the compressor running, it started off at 4.5 amps, and now it's just dipping below 3 amps. And if I let it run, I'm going to guess it's going to go back to about 3.8, 3.6 amps where it was before. And you can see that the transformer is holding the voltage steady, and everything seems to be happy. Okay. Now, what I want to show you guys is, if you notice, I have a fuse here. Okay, I have a broken fuse from my nice Fluke ammeter. Oh, there it is. It's back to about 3.8 amps at 14.4 volts. You notice I have a broken fuse here from my. This is a 10 amp fuse from my Fluke meter, and I broke this fuse actually measuring the current of this fridge. So that means that when these ammeters sample, it samples maybe every 50, 100, maybe 200 milliseconds. But that means this fuse broke because there would have been an initial spike of amperage over 10 amps. So that means that this fridge was drawing over 10 amps for maybe a really brief amount of time, which is why this fuse blew. I didn't measure it on the ohm meter. I didn't measure it on the ammeter because I didn't measure it on the ammeter because, like I said, it only takes a sample every, let's say, 50, 100, or 200 milliseconds. That's it. Okay. So again, that brings me back to either the problem is the the compressor is drawing too much current, a defective compressor, my boat battery is a little bit weak, or I just have too many small voltage drops between the battery and the fridge that's adding up to a big voltage drop. So I imagine that the problem may be a combination of the three, I don't know. But anyways, so this is my solution. The fridge seems to be working fine. Okay, even with the input voltages of only 11.8 volts, the step-up transformer can kick it up to 14.5 volts, enough to keep the fridge running. And I think it's going to work. Okay, so that's what I'm going to do. What I might also do, just for fun, is I might wire up some kind of a voltmeter ammeter here, so I could actually see the open circuit voltage and the amount of current that this fridge is drawing as it's running. So if I could put it here, maybe run the wires along the side of the fridge here like this, okay, and come back down there or something. That way I could see the open circuit voltage and the ammeter. And if I see the ammeter running at 3.8 volts, and I know that the compressor is running properly, cycling properly. I'm going to close the fridge door now, and then yeah. So that's the setup, and that's my proposed fix. I don't actually think that there's a problem with the fridge, or maybe there is. I don't know. I don't think it's a problem with the control module. I think it's actually doing its job. So you can see that as the fridge is running, it's settling into a amperage of 3.7 amps at 14.5 volts. Battery open circuit voltage is 11.8 amps. 11.8 volts. Step up transformer. Okay, and the actual draw from the battery is about 4.8 amps. But of course, you may be thinking, well, 4.8 amps, isn't that a lot of draw? Yeah, but the fridge doesn't run continuously for like a whole hour. It's going to run for a few minutes and it's going to shut off, right? It might run. It'll run longer for now because the fridge is warm, but normally it'll run for maybe a minute, hardly, and kind of shut off. Okay.